All right, so today our goal is to learn the difference between inductive and deductive reasoning. So first, it would probably help to define what does it mean to be inductive, what does it mean to be deductive. And if you look up the definition for inductive, you'll find many definitions. And probably the most simple definition I could give you is inductive is when you go from something specific to something more general. Reasoning. A female student, 2 female students, 3 female students, 4 or 5, all 7 females, all 7 students in this room are females. Okay, those are very specific things. And then from there, my reasoning, I'm going to go to something a little more general. I conclude that in this block is female. Is that true or false? Is it true? I don't think we have any males in this student, do we? In this class? So that would be an example of inductive reasoning, going from something very specific to something more general. Okay. You all are students at Wyandotte High School. I conclude that you are all female. That's kind of going from general to general. Let me make it better. You all are students at Wyandotte High School. I conclude that this student is a female. Going from something big to something smaller. And that's what we call, if you flip your paper over, deductive reasoning. And deductive, from something general to something specific. Does that make sense? All cats don't like water. Let's say that's my statement. True or false? Let's just say this is true. And then I conclude, anyone have a cat? I conclude that your specific cat does not like water. Is that true? Yeah. So that's true. Going from general to specific, it's only true if the first statement is true. Does that make sense? So, deductive versus inductive. And deductive, this is conclusions based off facts. Usually what you'll see when you're doing word problems, because the skill today is, can you tell me the difference between deductive and inductive? When you're doing deductive, you'll start off like all or every, and then it'll go to like some or this person. And when you're doing deductive, you'll start with this person or a person, like all people. Here's an example. Someone stole gold from a museum near the park. No one saw the thief take the coins, so there's no witnesses. And we don't have a description of the robber. Slylock Fox suspects, he thinks, one of the creatures in the park is a thief. So this detective, I don't know if you've ever done these comics, but this detective, there's no one that saw what happened. We don't have a description of the robber. But he thinks he knows which one's the thief. So he's going for something broad, something specific, like you are guilty. Okay. So who do you think he thinks it is and why? This turtle that just pretend, maybe he's just pretending to be a newspaper and a thief. Is it this, what animal is that? The wolf? A wolf with a bag full of stuff. And this is the sidekick. Is it this guy? Maybe he's pretending to ride a flag kite. Is it the guy painting? Is it the two on the seesaw? Is it the bird flying above? Or is it a mouse? What is that? What do you think that is? So which one do you think is guilty? Who? Which animal? The fox? Well, the fox, he's the detective. So he's not the thief, okay? Well, I'll give you a hint. He thinks it's the raccoon. Seesaw. Have you ever been on a seesaw with anyone else before? Like a bigger brother, a bigger sister? If you both sit on it, who goes down, who falls down? One that weighs the least or the most? The one that weighs the most, right? And it's like a raccoon, and I suppose that's a bear. The raccoon is a lot smaller than that bear, yet when his feet aren't on the floor, so it's not like they're pushing themselves up. And remember, these are coins. Coins are heavy. So, what conclusion do you think it is? It's the raccoon. He what? Has something to do with weight. One would predict that if a bear and a raccoon sat on the seesaw, that it would be the bear on the floor and the raccoon in the air. However, our raccoon is on the floor. Therefore, he must have something heavy in his pockets. And we're looking for a thief, so I think it's the raccoon. Does that make sense? So this is an example of deductive reasoning, going to something more specific. Inductive reasoning is going specific to general, and it's more so reaching a conclusion based on a pattern. So I made a conjecture just a few seconds ago. It is possible that that raccoon is not guilty. But my conjecture is that he is. Okay, conjectures are not always true. It's just an educated guess. So the word conjecture is an educated guess. Does not mean it's true. You'll see a lot of conjectures in mathematics. So we're pretty certain they're true. However, there's not definite proof that it's always true. Let's make our own conjectures. My dog chews on bones. Right? That's something very specific. That's about my dog. Another person named Austin, his dog chews on bones. Another specific case. So we have two dogs that like to chew on bones. And by the way, there aren't really any fully correct answers. So based off those two very specific examples, let's go to something more general. So if this dog chews on bones and Austin's dog chews on bones, what would be something that's general? And a hint, I almost always use the word all, because you're going specific, specific, and then general. What can you say? You can say, yeah, most dogs chew on bones. When you're going to something a little more general, you'll see most sometimes, but let's just stick with the word all, okay? Yeah, all dogs. Guess I can't spell dogs. All dogs chew on bones. Can you guys see it? Oh, that's not a very good color. It's a nice looking color, but nice. All dogs chew on bones. Is that true? If you have a dog, it chews on a bone. My dog doesn't. I bought him all kinds of bones. He will not chew on bones. He doesn't even like treats. Okay, so using reasoning, that does not mean it's true. You're taking very specific cases and going to general. A lot of times inductive isn't true. Will Smith. Do we know who Will Smith is? Yeah, the Fresh Prince. Anyone not know who Will Smith is? He's been in a lot of movies. He's a really good actor, right? So Will Smith, he won a Grammy for rapping. Did you guys know that? And he won an Emmy, so that's a very specific case. He won a Grammy for rapping. That's one case. Another case. He also won an Emmy for the Fresh Prince of Bel-Air. Another specific case. He's been nominated for 3 Oscars. So 3 very specific, and I am trying to go from specific to use inductive reasoning. So what can we say about Will Smith? He's what? You have to talk a little louder. What? He wins a lot of awards. Okay, yeah, that would work. He wins a lot of awards. Anything else? A lot of these, there's not just one answer. That's why when I gave a test last year in MTA, almost everyone got a high score because there wasn't really one answer that was correct. Huh? He's a rapper. Well, that was something that's specific, right? So you're going from something a little more broader to something quite more specific. But I would agree. If you win a Grammy for rapping, and then you're a rapper, but I would say that's more of deductive reason, going for something general and more specific. Okay? So we want to go on a Grammy, he won an Emmy, and he's been nominated for 3 Oscars. So something general. And yours did work, okay? So I'm not trying to say it didn't. Will Smith. And again, this is just the answer I got last year. This is definitely not the best answer. Will Smith, I would say, is talented. And what you said, you could leave yours on there. Yours worked. Okay? That's true. Is it? It's definitely an opinion. You will find people who they don't like Will Smith movies. They don't like watching them. They don't think he's talented. They don't think he's a good actor. That's not me. You're good. It's very easy when you go from very specific things to go to something more general. And you see a lot of that all the time, right? All right, here's one. 1 times 0 is 0. Negative 23 times 0 is 0. A fraction of 14 over 97 times 0 is 0. 3 specific cases. What is my conjecture? Anything, let's say any number multiplied by 0 is 0. And notice how we went from specific to general, any, all, every. That's what you'll see. Does that make sense? So do we understand inductive reasoning? Now, deductive is when you go from more general things to something very specific. So Josh rides the bus. Okay. He plays football. Practice gets over at 5. So those are all, it's not a very good example. You're going from, these are more specific things, but now we need to go to something even more specific. And by the way, deductive reasoning is more likely to be correct than inductive reasoning. So anytime you read something that just seems completely false, it's more than likely inductive reasoning. The patterns you guys did the other day, that's inductive reasoning. You looked at patterns like 2, 4, 6, and then you made a conjecture about what the next number is. That's inductive reasoning. But it could have been 2, 4, 6, 7. Maybe that wasn't really a pattern. So Josh is a student, rides the bus. He plays football. Practice gets over at 5. What do you think Josh is going to do? Huh? Go what? Can you say that louder? He goes home? Okay. Yeah, that could work. But he rides the bus, so maybe we could say he rides the bus home, be a little more specific. And even more specific. Since practice is over at 5, he's not taking the regular bus home. He's taking the late bus home, right? So Josh will ride the late bus. Or take the late bus home. Something along those lines. He's a student. That's something a little more general. He plays football. Something a little more general. You could say that those are more specific, depending on your argument. Practice gets over at 5. And so we're going from more broader things to something very specific. He took the late bus home. Luke has a pet lion. Anyone else have a pet lion? No? Luke forgets to feed his pet lion sometimes. Any conjecture about Luke?